All right, welcome everybody. Today we were talking about arc length and sector area. So in our last lesson, at the very end, we talked about circumference. Let's do a quick review of that. We have the circle with a radius of 8. So if we want to find the circumference, it's always 2 pi times the radius. So here we would put 8 in for r. Again, we want to have exact answers. So you wouldn't want to put the whole thing into your calculator unless your calculator can handle keeping pi separate. So we really just want to multiply the 2 and the 8, so we'd get 16 pi, and our unit is miles. And then similarly for area is pi r squared, and r is 8, so 8 squared is 64, and again we want to keep pi separate, and we would get the unit miles squared, right? Because we're doing 8 miles, and that's being squared. So 64, and then miles is also being squared. Okay? All right, so that's circumference, that's area. Okay? But what if I ask you to find the portion of the circle? Like what fraction of this circle is being bolded? Okay? And I had a lot of students say, ooh, it's a fourth, or 1/4, 1/4. Okay, and I asked, well, how do you know? How would you know for certain? Well, we know that they give us 90 degrees, and a whole circle is 360 degrees, and if you were to put that into your calculator, that would just reduce to 1/4. Okay, and then the next part is find the bolded part of the circumference. So they're just asking us to find this part. Okay, again, it's part or a fractional part of that circumference. So we know the circumference already. This is the same. These are like this one and this circle and this circle. Those are all the same. So we already know the circumference. The circumference is 16 pi miles. But we just need to multiply it by a fourth, right? We just want a fourth of that circumference. And if you multiply a fourth times 16, we would end up getting 4 pi miles. So that is actually called an arc length. So part of a circumference is called an arc length. I'll mark that here, arc length. All right, and then the next thing is what portion of the area is bolded. So if we were to shade that, again, now it's like this whole thing. We want to know this whole area. Okay. Well, then we already know what the area is, but we just want a fourth of that. So we could do 1/4 times area, which again is up here, 64 pi miles squared. And if we multiply a fourth of 64, I think we end up getting 16 pi miles squared. Okay, and this is called sector area. Sector area. All right, so that's pretty much what we're covering today. So we're just taking the same thing we did last time. We're taking that circumference, we're taking that area, but we just want to multiply it by a fraction of that circle. So here, what would be the fraction of this circle? So we kind of think of it the same way. We could do part over whole. So 3/15 is the part that we want out of the whole. And we could use our calculator just to see. We would get 7/8. Okay. So if we want to find the circumference, or that part of the circumference, we would do 7/8 of that circumference. I think we just said it was 16 pi. Should double check up here. Yep, so 16 pi. And if we use our calculator, we would end up getting 14 pi miles. And then for the area, again, it's the same, the fraction of that circle, so 7/8. And we can times it by 64 pi, and we'd end up getting 56 pi miles. Okay, so one thing to be aware of is that you don't really, when we do this, if you're going to put this into your calculator, you do not need to reduce your fraction. Your calculator will take care of it. I just did it here so that you can it's easier to visualize 7/8 than it is 315 out of 360, okay? So you're welcome to reduce it if you wanted to, but I'll give you an example coming up with the problems on the next page to tell us that we actually don't need to reduce those fractions separately. All right, so arc length. So let's do a few problems of this. Write down our final formula that we would use. So again, arc length is a length, right? We call it L. L is equal to the fraction of the circle times the circumference. So here we had a fraction of the circle. Again, you're going to be given some sort of angle. We call that theta over the 360 degrees. So like for this example to the right or left, sorry, theta would be 300, okay? And then we just want to times it by the circumference, which is 2 pi r. You're also going to see problems that are where the angle is not in degrees, it's in radians. So we talked about how for a circle in degrees it's 360, but in radians it's 2 pi. So besides that, we're going to use the exact same equation, okay? The angle over the whole circle, or a whole angle of the circle, is 2 pi times 2 pi r. And you're going to see that some of the things for radians is going to cancel out, which will make it a lot easier for you. It's one of the good reasons why we should maybe focus on radians instead of degrees, especially as we get into higher math. Okay, so we'll do maybe one of the degrees since we already did one on the first page, and then we'll do a couple of the radians because that's the one that people kind of struggle with. So again, if we want to find the arc length, we want to find the fraction of the circle, so 300 over 360, and we're going to times it by 2 pi times the radius, which is 2 feet. And again, we're going to put this into our calculator. If you have a Casio, you can just type it in exactly how it is. You wouldn't put the feet, obviously, but you could do 300 over 360 times 2 pi times 2. If you have a TI, or if you don't want to have to type in pi all the time, you could just type in 300, divide 360, times it by 2, times it by 2, and then just remember that when we write down our answer, we need to make sure pi is still part of our answer, okay? It's not forgotten or canceled out or anything, okay? So if I hurry and grab my calculator and I type in 300, divide 360, times 2 times 2, if you get a decimal for like a Casio graphing calculator, you just have to push the SD button. For mine, it would give us 10 over 3, but don't forget the pi, so 10 pi over 3. If you have a TI, then you need to push math frac. Okay, so math frac, that will give us a fraction. So the decimal, if I probably should have written that, was 3.3 repeating, and then you could switch it into a fraction. Okay. All right. I'm trying to think if there's anything else I need to remind you. Oh yeah, one thing I guess I should mention it now. On the review and on the test, I think maybe on the homework as well, it will ask you to come up with your answer in exact and also approximate. Okay, so to find approximate, you just put your answer into the calculator and see what the decimal looks like. And you need to include pi. So you would type in 10 pi divide 3. Okay, I'll do that really quick just so we have an example of that. And so if you have a Casio, you might as well just put pi in onto your calculator so that you can easily switch it over. So here this is the same as 10.47 if we rounded to 2 decimal places, and would do, I guess it's feet. So the nice thing about exact answers is there's no rounding error. It's perfect. Where we have approximate answer, which I think sometimes is more easy to kind of understand, or I know what 10 feet is. but I have no idea how long 10 pi over 3 is, right? So they're both great in their own ways, okay? All right, but for your homework, I think this is, well, I would do both. Just do both. It's great. All right, we'll skip B and we'll go and do a couple of radians, okay? So again, same thing. We'll do the angle, so pi over 3, over the angle for a whole circle, which in radians is 2 pi. And a lot of people will forget that, and they'll put 360, and they'll be like, Mr. Warner, why is my answer so small? Okay, and it's because they did 360 instead of 2 pi, because 2 pi is like 6.28, which is a lot smaller. So it makes a difference. You can't do 360 here. And then we'll times it by 2 pi r, which is 6. So one thing that's nice, again I mentioned, is that if it's in radians, then we can just cancel out these 2 pi's. And now in our calculator, we can just type in pi thirds, or pi divide 3, and then times it by 6. And that's a lot easier, a lot less stuff to do, okay? So if you have a TI, then you'd maybe want to do 1 divide 3 times 6, and you'd end up getting a 2, and then you'd add the pi. If you have a Casio, you can just type this whole thing in, and you would get 2 pi. So both are great. And then if we want to find the approximate, then we just type in 2 pi, push the SD button, or if you have a TI, it'll just give it to you, and you'll get 6.28. And these are centimeters. Okay. All right, for everything else, I'm probably just going to do exact answers, just to save a little time, but if you have any questions on approximate answers, please let me know. All right, so last one here, we're doing length is equal to the fraction of our circle over the whole circle times the circumference, which is 2 pi r. The 2 pi's would cancel, and so I would type in 7 divide 4 times 8 if I was a Casio, or a TI. If I was a Casio, I'd just put the pi in with it. So 7 divide 4 times 8, and so I get 14 pi. So some of these are like solid numbers, and that's great. But again, sometimes you're going to have like fractions as like this. So it could be either way. Don't be surprised if you get a solid number like 12, okay? And then, or 14. 14, and we'll do 14. Actually, I said I wasn't going to do this again. 14 pi and then we look at the decimal. So that's the same as 43.98. Okay, and we're doing meters. All right. Okay, so the next half is to do sector area. So again, the nice thing about sector area formula is it's the same as the arc length, except we are doing the area is different. Instead of 2 pi r, it's pi r squared. Okay, so we'll still do the same angle over 360. We still want the fraction of the circle, or theta over 2 pi if we're doing radians. And then we're just going to multiply it by pi r squared. Okay, so let's do maybe 1 in degrees and then 2 in radians, and we'll be good. All right, so area is equal to the fraction of the circle, so 45 over 360. Actually, I think I wanted to do this next one. Let's do this one instead. So area equals 120 over 360 times pi r squared, so 16 squared. Again, we'll just put it in how it is if you want to leave the pi out, or put it in if you have a Casio. So 120 divided 360 times 16 squared, and here I get 256 pi over 3. Okay, so sometimes you're going to have these fractions that are kind of crazy big, and that's okay. Don't be worried about that, okay? And our unit would be miles squared, because what we're squaring is the 16 miles. So the miles get squared as well. All right, a couple with radians. So we have 7 pi over 4 over 2 pi. And we're timesing it by pi r squared, so pi 10 squared. Also, one times if you type this all in, oftentimes you need to put a multiplication symbol if you have a number after the pi. So just keep that in mind as well. So what can cancel here is we can cancel out one of the pi's on the bottom and one on the top. So you can choose, you could cancel out this one, or you can cancel out the other one, okay? So you can cancel those out, we can leave the pi out on the right side. Either way, you're gonna have a pi left over. So we can type in 7, divide 4, divide 2, and then we can times it by pi if you have a Casio, where you have to keep it separate if you have a TI, and we would do 10 squared. Okay, so 7, divide 4, divide 2, times 10 squared. And then if it gives you a decimal, we need to switch it into a fraction. So we get 175 pi over 2 miles squared. All right, one more. So 5 pi 6 over 2 pi. And we're going to times it by pi r squared. Again, these pi's we can cancel out top and bottom. So 5 divide 6 divide 2 times 8 squared. And I end up getting 80 pi over 3 miles squared. Well, if you have any questions, please let me know. Hopefully that's okay. Again, you're going to have to spend a little time memorizing these formulas, but again, they're not too hard as long as you can remember the fraction of the circle and what area is and what circumference is, okay? Also, I've had students ask, well, how do I know if I'm using degrees or radians? So if you look at these circles, if you look at the angle, if it has a degree symbol, then we're using degrees. It's out of 360. If you have something like this where there's no degree, then we have to be using radians. So that's something you can look for when you're doing these problems. Okay? All right, well, we will see you later.